We are back with Doing the Math with Desmos, the online calculator that is free to all in just about every platform that's significant out there, including the Android, the iPad, the Chromebooks, and of course, Windows and Mac computers. We are going to continue a test that we took yesterday, that we started yesterday, and we're going to clear our calculator so that we can start that exam. And we left off at number 10, but first we open it up to a bit of artwork back here at the Desmos Lounge. This is artwork done using figures and algorithms and numbers and equations in the Desmos calculator to give us this very attractive artwork. In this case, we present this one in our previous video, the Desmos bar by Ezra Oppenheimer. And that is also in the top 3. We have a work of art called Mesmerized by Chloe Lum, and you can find those in the Desmos contest. Do a Google search for that. I will provide the link later. And this is an example of what can be done by using equations, figures, and calculations in Desmos to create artwork. But we are going to go to something a bit more mundane, which is testing. And in the state of Texas, that is the state Texas STAAR, state Texas assessment. And we are going to continue with number 11. And keep in mind, in this series, we try to look at how Desmos can help us to answer specifically test-related questions or questions on the test. Not all of them will lend themselves to being, or Desmos does not lend itself to doing all of the problems using the online graphing calculator, but a good number of the problems can be done using the calculator or a competing calculator. Now, in this case, I see one here that does not need or for which the calculator probably will not help you, and it requires you reading the question and determining what is being asked and making conclusions, drawing conclusions about what the question is asking. So a student worked out at a gym continuously for 50 minutes. The graph shows the remaining percentage of the workout as a linear function of x, time in minutes. Look at it, and here we're not going to be helped by plotting the points. And in fact, all of the information we need is both in the question and in the answers. So let's look at it. The graph shows the percentage of the workout as a function of x, a linear function of x. So we have our x-axis along the bottom and our y-axis. And notice the numbers, 0 to 50 and 0 to 100 on the y-axis. And let's look at our question. The question is, which answer choice best describes the domain and the range of the function of this situation? And our students going into the test are taught that the domain, we're talking about x, and the range, we're talking about y. So our x's and our y's. Okay, our domain and our range. Okay, so domain y, domain x, range y. And I encourage my students to label these on a paper or note them on the day of the test. And although I would not be using Desmos for this calculator, I can make notes. I can use this as a scratch pad. Domain, remember, is x, and range is y. Just in case I'm going to use this to make calculations, I can look right over here at my notes. So I look here, and which answer choice best describes the domain? Okay, that's the first part of the question. So looking at them, all of the options make reference to the domain. So it's not going to help us to eliminate any of them because they don't say the domain, all of them. And all of them make reference to the range. So what stands out in each of these that I can eliminate a choice? So the first one says domain is all the real numbers equal to or less than 0. And I can make notes to myself. And I'll say here, okay, this one is saying equal. So all of the, let's say all of the real numbers equal to 0. Here's my 0. And less than 100. But I don't have 100 here. That my 100 is in reference in the y. So that's curious right there. And then the second part of A says all of the real numbers greater than or equal to 0. And let's see, greater than or equal to 0, less than or equal to 50. And I'm noticing in A, when it talks about the y, oh, excuse me, this is the x, right? So x, yeah, x 0 and 100, so that doesn't match up, right? So then the range gives me a 0 to 50, and the range is actually over here in my y's. So that's not matching up. So look at B. B has a number, -2 for the domain, and the range is 100. So the range I see is 0 to 100 here, but what is this -2 making reference to? I'm not sure. Could it be the slope? I mean, that could make sense, but what does that have to do with the domain and the range for this graph? It's not a question of slope, is it? All right, let's move on to the next one. The domain in C, all the real numbers greater than or equal to 0 and less than or equal to 50. Okay, and so that makes a reference to 0 to 50. Okay, so that domain makes a reference to 0 to 50, and those numbers add up, or they match up at least. And then the range is all the real numbers greater than or equal to 0, less than or equal to 100. Okay, I have 0 to 100 here in the range column, in the range axis. So we have a match there. And then the final one says domain 100, range -2. Domain, again, this domain is 0 to 50, and we're not really sure what the -2 refers to. And working on Desmos is probably not going to bring me any closer to an answer to this. So I make a guess. Well, the numbers in C seem to relate to what I'm seeing in the graph, 0 to 50 for the domain and the range 0 to 100. So let's make the best educated guess and take C, because that's matching the reality of this, or the information in this graph. We'll go to our answer key. And let's see, 11. We're on 11. Let's get rid of all of this drawing. And our answer is C. See that? We didn't need the Desmos. Moving on to the next question in this exercise, we are looking at a series of graphs, and Desmos graphing calculator, that's its bread and butter, isn't it? It's the series, the graphs, the power of the graphing calculator of Desmos. And so we look at the question. And question 12 says, the graph of quadratic parent function y of f was transformed to create the graph of the g of x equals the f of x plus 2 minus 5. All right. So we have to teach this to the students, as I have related before, that the g of x really simply means the y. And I'd rather keep it in those terms. The y equals what's on this side of the equation. And I like this equation. It's clean in a sense that my y is by itself. And I look over here as the x by itself. Well, I don't like this here, the f of this function, the function of this relation or equation. I don't like that because it just gives students a tripping point at which you look at it and you say, well, that's f times x minus 2. No, if you look at it, it's actually talking about the function. And I don't like the way that that is set up. And I will ask you, and I will ask my students to simply disregard this f because it's very much looking like a function of. And so treat it simply as the value of this after the function of, just like the function of x is just y. And it seems a little overly confusing. You just have to get the students, or you, if you are a student, have to do enough of these problems to recognize when that is a simple slope question, slope equation or equation of a line. Okay, and in this question, it's the equation. Aha, it's not the equation of a line, is it? All right, so I used the wrong term. We use the name for this as a parabola, but we don't even have to say that. What we have to recognize is look at the question, the quadratic parent function, f, the quadratic. So what I have to remember is that when I see that, I'm actually not looking at a line, and it's obvious from the graphs, right? Quadratic functions, we're now talking about parabolas. And so we go back to our formula sheet. Look at our formula sheet over here. And where does the word quadratic appear? Well, quadratic equations, there's a whole section on them. Let us look, and in our question, we have, let's see, some quadratic equations. This one looks like, I guess this is it, the function of this statement here. Okay, the function of x, which is just y, and something is before that, this equation, and we call that the vertex form of the quadratic equation. So it's a stretch, I understand, but the clue for us would be that it's in that function form. It's in that function form. You see that? Let's get back to that. All right. Again, we're stretching here, I understand. So just have to do enough of these to remember it. Okay, so we have to put that into a format that looks like our formula chart, excuse me, formula chart, which is, again, this is a famous formula over here. I have to refresh that. So the way that is set up is a clue that we're looking at our quadratic equations chart, and you therefore see that there's something missing from here. So we have the function of x, the g of x, equals a function of this minus 5. So what is missing from that? Well, let's go ahead and start to set this up in the Desmos. I caution you, I would prefer to use g of x or the y equals, and I'm going to put my f for now just to set it up. This is set it f of x plus 2 minus 5. Let's see, x plus 2 minus 5. Minus 5. Okay, so that looks like our equation. But there is something on the chart that you must make a note of. Please notice this, that because the question's talking about quadratics, and I look at the one, and the one closely related to that is the one in the vertex form. And what do you see in this formula that you do not see in the question? You don't see the a, do you? We don't have a number in front of a, and that's why I don't like that function sign. But we do see a square there, don't you? I'll zoom in on that. You see the square? Okay. So let's go to our problem and notice that it doesn't have a square. So let's put that in the vertex form and put that into Desmos. So we look here and we put that, open up our keypad, square that number with our square function here, our square button. And you must do away with this because you're not actually multiplying the letter F. You're not multiplying that letter. So now you have it in quadratic equation format. This is the vertex form of the quadratic equation. And notice what it says. It says, I don't understand the way that's here. Well, when you get that, then there's something here that's wrong. So let me take a look at it. And x plus 2, and I look here, it's x equals 2. So a typo there, a very serious typo, serious error. So now you understand and you can see what our graph is giving us. All right, so we have a parabola, which is what a quadratic equation will give us. We can see where the zeros are, and they call them zeros because it hits the x-axis at 0. Excuse me, no, it hits the x-axis, right? And they don't go up or down. There's not a value up or down in the y, so they're called zeros. And you can go ahead and verify that, but that's what they're called if you're asked about those 2 points. But in this case, you're asked about the form, aren't you? And nothing more. It says, what over here best represents this line? Or which is best represented by this equation here? All right. So we take a look, and we now have a graph, and I have let's see, I can identify that that's a -4 and -4.2, and I have over there, I have a 0.2, okay, both at 0, and I'm gonna go over here and see which one. And so this one is definitely not looking like our graph. Okay, looking at this one, and this is 4, and I might have to zoom in a little, right? Let's look at H. Let's zoom in a bit, and I have a -4 and something between 0 and 1. Let's look at that. Look at that. Something between 0 and 1. Okay, so that looks good. Something just beyond -4, just to the left of -4. And something just to the right of the 0, but not yet getting at 1. And that sure looks like something in the graph of Desmos. And so I want to go ahead and say, well, that's okay. Well, I have 2 confirming marks right there. I have my -4 there, right? And I'm going to give myself a check for getting that other value over here. Let's go over to the next graph. That looks good so far. And in this one, what do I have? I have it in the other way, in the other direction, don't I? Okay. This one is on the left side of the y-axis, pretty much. This one is mostly on the right side of the y-axis, so that's not the one that I want. And in this one, definitely not the one that I want. Doesn't match at all to the size, the value. All right, and so we're more comfortable in saying that certainly looks like the way I set up my problem. But again, it seems like a stretch, doesn't it? You're just gonna have to accept it that when they're talking about quadratics, you should be able to see something that looks like that expression. And we do, and we choose to take H. Let's look at our key, and we look at, what was that, 11? You can look at your TEAG, and looking at C, we're looking at, what's the second? What number was that? Oops. Here we go again, having to refresh. All right. Keep track of what number you're on the day that, so you don't want to bubble the wrong one, do you? All right. And while that's is going on, all right. So we were at number, if you do a few of these, you kind of, let's see. All right, so we did 10, 11 was the one we didn't use Desmos for, 12 is the one we actually chose an H. We've already erased all of that, but I have not erased the Desmos, and definitely looks more like our graph there. So that is an H, isn't it? And our answer key, in fact, has, that was 12. That's why we didn't see it. It was 12, and that was H. And that's an H. Got it right there. So Desmos did a lot of the heavy lifting on that one, but it's you really want to go over your quadratic equations and understand the form, the format, how they appear in the chart, and how they're supposed to appear when you set them up. Now, here is a mathematical problem that you will need to really remember some rules about dividing numbers with variables and exponents. And Desmos can only help you so much here. It can help you do the basic math of the division and the basic math of combining those exponents one way or the other. So let's set that up, and we're probably going to be better served by some scratch pad. We can do this in a computer, and we can take notes, but for now, let's do it the old-fashioned way, because there's going to be a number of equations that you're going to really want to keep track of on a separate sheet of paper on your scratch pad, which you're almost certain to get even if you do take the online version of the STAAR or whatever state test you take. So let's start with, well, the basics, 45 divided by 15. So when we do 45 by 15, okay, 45 by 15, let's do this. All right, let's do this here, and then we'll talk about our result. Okay. Yeah. So 45 by 15 is the first calculation. And because I have it, I'm going to use the calculator. Let me go over to my calculator. We'll put that over here, and that's 45 divided by 15. And it gives us a 3. So, and we have mixed exponents. So we're going to have some at the top and maybe some at the bottom, because we have mixed exponents, and you just have to remember that if you're subtracting or adding, it depends, the subtraction or addition of the exponents depends on, or will lead you to have some at the top, some at the bottom, if you have any left over. And we'll go over that in a second. So 45 by 15, and we have a 3, and it's a positive 3. And you just have to remember that those positives will go on top. Well, let's go ahead and put that on top. All right, so little help from Desmos there. Now we have the m's, and we have a -6 exponent and a -2 exponent. And so we're going to add those together, because that's what we do with exponents. Okay, well, and it's going to get confusing here. Let's see. Yeah, let's see. Let's add those together. And in Desmos, it's going to go ahead, go back to Desmos. So let's see. So it was -6, and we're combining. Yeah, we're taking extra exponents. Top combines with the bottom, we're actually getting differences, -6, adding -2, but we're actually minusing -2, -6 minus -2, -6 minus, see, it gets tricky here. So I'm combining, but I'm taking away a negative, and this gets tricky. And I want to double check that. So let's see, I have a -6, take away a -2, and combining those, -6, -2, -6 minus -2. And this is why having the Desmos again is kind of helpful, because this can be quite tricky. -6 minus, see, I made a mistake. I think I made a mistake. So like, yeah, so -6 minus -2. Ooh. -6 minus -2. All right, good. See how that makes a big difference? All right, so let's see, -6 minus -2. Okay, and that is our answer, -4 on the M's. And the M's, yeah. And another tricky bit here that you have to remember is when it's a negative exponent, it goes to the bottom of your fraction. So those are the M's, and we put that M at the bottom, and it's a -4, and we don't actually show negative. We're by putting the putting the variable and its negative exponent at the bottom, we are saying that that is a negative exponent. All right, so there you go. So, and if you want, you could actually make a list of these things here, just to make a note of yourself, that yields you an M to the -4, just as a note. M exponent -4. Okay, just as a note. It's not going to calculate anything, but that just so you remember that that's why you put that M on the bottom. Moving on to the next one. So we have 3 here and 4 there. P's. So we have 2, take away, and it's a positive number. 2 and 8, combine those. We have 2 minus, and it's a positive number, so it's -8. It tells us -6, right? So those are the P's. Those are the P's. And is it positive or minus? Oh, did I forget already? Okay, it's a -6, so it goes at the bottom. All right. So we have our P's, mind your P's and M's. And P at the bottom, and it's -6. So we show that it's a -6 by keeping that exponent on the bottom of the fraction. Go back, and we have one more letter. We have a V and a V and a V, and we combine those. I guess I'm not sure if I should use the word combine, because that gives you the idea that we're going to add, but we're not. We're going to subtract, because that's what you do with exponents in letters. Okay, so back to Desmos. Okay, we are to M's, just as a, and we have our P to the 6th, right? Okay, and that's actually -6, right? Yeah, and let's not get confusing. Let's not get confusing. Let's get these off of there. Okay, it's gonna look like that, M to the 4, because it's at the bottom. Then a P to the 6, because it's at the bottom. And then our final one is the V's, and 12 minus -4. 12, take away the exponent at the bottom, clean it up, keep it clean by putting our number in variables, and it's a positive 16. So that it should look like V to the 16, yeah, to the 16. And a reminder that has to be on top. On top. Okay. All right, so this is what I'm going to do. I'm going to tell you that M to the 4 is going to be on the bottom. my p to the 6 is going to be, because I have a negative on the bottom, and my v to the 16 is positive, so it's going to be on the top. And let me put that on the top now. Let's see, do we put any others at the top? Let's see if there's anything left. Okay, 3v to the 16 and p to the 4. Okay, all right, that looks fine. Just doing my double check my math. I might want to leave that there to double check it later, because there's so many numbers and so many variables that you can make a mistake on any of this. So let's see which one matches. We are looking at, it's got to be an exact match, right? Because let's see. So we have there v16. Well, let's start with the m's. M to the 4 at the bottom, p to the 6, and v to the 16, and those numbers match up. And if we did the math correct, we should be getting the right answer. Let's take a look. That was 13. B. Is that what we said? Yeah, B. All right. So Desmos did the math for the division, for the combining of the like terms. It keeps us in order. So when we have all of these negatives and positives floating around, it gives us a sense of where we want to put things in place. So thank you very much, Desmos. We're looking at a question that asks you, what is the positive solution to this equation? So let's, so it's an equation, and it's asking about the positive solution. Record your answer and fill the bubbles on your answer sheet, so you don't have a multiple choice. You can't guess your way out of this one. You actually have to create this line, and it's really not a line, right? What are we looking at again? Quadratics, right? Quadratics, parabolas, smiley face up, smiley face down. Okay, so in this case, we take this equation and let's put it into Desmos. Okay, make sure you copy it correctly, as you can see. Make sure that you have the, I don't have the square here, it's a quadratic, it's going to require some sort of a square. And squaring that, and I have the same values here, 4x squared plus 12x equals 135. But I do not have anything on my graph. I don't see anything on my graph. So what could be wrong? It says here, plotting implicit equations and inequalities is disabled, but wait a second. We had a quadratic before. So is it in the quadratic form? What is the quadratic form? Remind yourself by going to your chart. Let's go to your chart for the quadratic equations, and we take a look at what it's supposed to look like. And it is flipped through if you have a paper. Okay, there's a vertex form of the quadratic equation, but we also have the standard form of the quadratic equation. Quadratic equation standard form, function of x or y is equal to a number in front of an x squared plus bx plus c. And remember, if there is no number in front of the x squared, it's just a 1. So taking a look at that, I go back to my problem. And let's see, it's a quicker way to get to it. But let's just get back to our problem. 14, I believe it was. Okay. And there it is. Oops. Yeah. What's the positive solution set? So we have to get that into quadratic equation format. And we don't have it as such now. So what does our quadratic equation format look like? It's usually y equal, the function of something equals. And I'm not going to change any of the values. I'm not going to take away. I'm not going to to take away. I don't have to, right? Because the y is by itself. I can keep the y by itself. So let's see. Now, okay, we do have a 135. What do we do with that? Okay, let's do this. All right, let's bring it all to one side. Okay, so I have that 135 to deal with first. So this becomes, we take away 135, take away negative 135. Okay, from both sides. Making a note to myself. So once I do that, and again, this is where your scratch pad comes in, right? Take 4x squared plus 12x equals 135. Okay, we take away 135 from both sides. It's we're over here at the beginning. Negative 135. That could be neater, but just give me an idea. I'll clear that up. It's looking sloppy. Okay, let's make it neat. 4x squared, I might do that space, 4x squared plus 12x equals 135. Cancel out that 135. We want to keep this into all of them, putting them here, and I could just write it negative 134. But I want to remind you where it came from. We want to remind ourselves where it came from. So we're left with, cancel that out. We're left with a 0 here on this side, and so we're left with 4x squared plus 2x plus that 135. And it's looking very sloppy, but I will just go ahead and remind you that I can just put it right here. And I want to put it here because I want to get that graph. So I now have 4x squared plus 12x plus 135 now. Okay. And that equals 0. Okay. Do I have my line? No, because it says that's still, you're still trying to do an equation. Okay. All right, let's see. Plotting implicit equations is disabled. Okay. Now that's still a problem. But we know that from our earlier question that quadratic equations are possible. So what format did it have? Well, what it had was, it had a y equals the quadratic equation. And you'll see that it's still not appearing on the graph. What's the format for the quadratic equation? Go back and look at it. And that's why sometimes I ask you to actually write the quadratic equation. It starts with a y equals. So let's keep to that. Y equals. So now we're not going to change any of the values at this point. We're just going to flip it over so that the y is on that side and all of that is on that side. So we're not taking away anymore. And we're not making negatives out of positives, positives out of negatives. We just flip it over and keep it balanced. We're going to keep it balanced by just flipping the sides. So that actually is telling you y equals 4x squared plus 12x plus 135. Okay, so I press enter. What do I have? Okay. All right. I have this in this equation form. All right. And let's go back and look at our problem. And we're back at that. And let's see, 4x squared plus 12x equals 135. And Desmos, and hold on a second. 135. Nice. Okay. That's odd. That's odd. That doesn't seem correct. If we're looking for a positive solution, that means that something is hit at some axis. Okay, and we don't have multiple choice, so let's figure out where we went wrong, where I went wrong. Let's see, -5, 135. Take away 135 from both sides. 135. Take away from 135. Okay, all right, hold on a second. Take away. If I'm taking away and I'm putting on this side, this becomes a negative. So why did I put, so 135 plus 135 is doubles that. So that right there is a negative. And if that's a negative, then that becomes a negative. All right, that becomes a negative. So gotta fix this up. This is actually a negative. You made a mistake. This should be a negative. All right. So let's clear all this up and say that take away from both sides 135. That therefore that gives us negative 135. Okay. Little note there. Okay, there you go. So that right there is in error. So that was an error there, okay? And if it was an error there, then that carries the error over. So we have to make that a negative. Enter, all right? So let's see, let's go over that again. Our original formula from the question, we put it into Desmos, not giving us anything. Take away 135 from both sides, put that in that format where everything is equal to 0. That's where that came from. We're missing that step there. At some point, this was equal to 0. Okay. All right, and it's still not in the quadratic notation in the format that you see on your quadratic equation chart. So we do that by making it equal to 0, flipping them over, or putting the y on that side, everything on this side, keeping it balanced. We're not changing the values anymore. And now that I have that negative 135, let's see, these figures, they are giving us zeros over here, but the question, it means they cross the x-axis at 0. So how does that help us? Read the question again. What is the positive solution to this equation? What is the positive solution? We have a negative x here and a 0, and a positive 4.5 here and a 0. So on the positive side, the positive solution is a 4.50. You put it in your grid, and the positive would be 4.5. Would it be 4.50, 4.5? I'd have to look at what they give you for a grid. Let's take a look at the grid. That will be on your answer sheet. So be very careful what they're asking for here, because I'm not sure if the grid would be asking for 4.5 or 4.50, the coordinate. Not sure exactly, but we have a positive value in 4.5 that comes out of this equation, the steps for which we just did. And so let's see if the number 4.5 or 4.5 comma 0 appears in our answer sheet. Go to our answer sheet. Let's make it official. We think it has something to do with that. Okay. Let's go to our answer sheet. Number 14 is testing 0.8a, and we have a 4.5. 4.5. And how could you do this without a graphing calculator? Thank you again, Desmos. A wordy word problem. A grill at a barbecue restaurant will be used to cook sausage links that are 2 pounds each and briskets that are 6 pounds each. No more than 120 pounds of sausage links and briskets will be cooked on the grill. All right. Which inequality represents all possible combinations of X, the number of sausage links that will be cooked on the grill, and Y, the number of briskets that will also be cooked? I don't see a graph. I see that even if we put in these inequalities, Desmos testing version does not do inequalities. So what is this word problem asking me? Well, let's see. This is my setup where I'm going to have, one of these is going to be an X, one of these is going to be a Y, and there's going to be a maximum value, something that is totaled. Okay, let's see. So let's say we have two objects, two things, and they are sausages. Let's make those X. Okay, sausage links are 2 pounds each. X equals 2. All right, briskets. So briskets are going to be the Y. The Y over here, all right? Okay, so if the Y is going to be equal to 6 pounds each, Y equals 6. X equals 2, Y equals 6. All right, and no more than, that's up to, it's the maximum. And there's our no more than, it's our maximum of 120. Okay, so no more than. So it could be equal or it could be less than. So do we have any that we can throw away? Okay, let's see. All right, 2 pounds each. Wait a second. Take a really good look at this. Sausage is X, and they're 2 pounds. Briskets are Y, and they're 6 pounds. Okay. All right. Okay. So let's see. So wait a second. Maybe this is wrong. It'd be easier if I just did these offline and instead of doing them with you, but I really want to get the sense of working these out as I'm on the test. Okay, so let's see. Let's see. All right, help me out here, guys and gals. All right. So no more than, it means 120 pounds. Okay. And let's see, the sausages are going to be 2 pounds each. So let's see. We're doing something to the sausages. Maybe it's, okay, 120 pounds. Okay. So 2 times, okay, so 2 pounds. So 2 pounds times the number of sausages is in our equation. So, right, 2 pounds times the number of sausages plus 6 pounds times the number of brisket. Okay, right, let's see. Sausage links are, so X does not equal 2. X is just, X equals sausages. X equals the sausages. I gotta be careful about that. X, and Y does not equal 6. Y is actually the, this is, Y is the sausage, Y is the brisket. Y is equal to the brisket. Let's make that a little neater. Y is equal to my briskets. All right. And briskets and sausage total will be 120 pounds, right? No more than, yeah, sausage links and briskets are going to equal 120. So 2 times the pounds of sausage plus 6 times the pounds of briskets will give us 120 pounds of meat. 2 times the pound of sausage and 6 times the pound of brisket will give us 120 pounds. All right. So let's see. Let's choose our answer. And let's see if that's right. Number 15. So B. B, yeah, 2 times the sausage, 6 times the brisket equals 120 pounds. Wow, I'll feel more comfortable at this point just getting back to a Desmos type of graph. Just a sampling of the art that is created in Desmos, and you can even look to yourself and look at some other creative ways in which Desmos is being used to create artwork for Desmos. This was the Desmos art contest, and you can see for yourself. You can just Google Desmos art contest, and you can see for yourself some of the illustrations that were done doing Desmos. But getting back to the test, let us get back to the test. And we saw that 4 out of 5, oops, answer sheet. 4 out of 5 of our questions, well, no, excuse me, 3 out of 5 of the questions answered were in Desmos, or were made use of Desmos. So we're looking at 20, 40, 60% of the last 5 questions on the test lent themselves to being able to use Desmos, or Desmos could be used in 3 of the last 5. So you add those to the 90% of the last 10 questions, 60% of the last one is still a pretty decent amount of questions that can be answered by using Desmos. Which expression is equivalent to all of this in this parentheses added to all of this in the second set of parentheses? So we have how many terms? So we're combining like terms. Can Desmos help us? Well, there's some basic math there, and I do worry some of my newer students, particularly if you don't have a lot of preparation for algebra, for combining terms with exponents, variables. Well, let's get right down to it. We try to recognize that there are how many types of variables? We got some R squares, right? We got some R squares. And let's do that. R squares. We have a series of R's, and we have a whole number, right? So we have an R square, some number of R squares, and let's make a little grid. We have a number of R's, and we have some kind of whole number. So let's combine these terms, and let's use Desmos to do it, since we have that fantastic calculator to help us with the basic math. Let's count up the R squares. I have negative R square, so the number in front of, the number in front of R square is a negative something. And if it's not written, it's a 1. So let's go to the calculator. And we have negative 1. And then we are adding the other R square. And what's in front is a negative 6. So we're adding, let's be careful here, let's put our parentheses, negative 6. Okay, so we have a plus 1 and a negative 6. And remember, Desmos is not going to allow you to combine the variables, because it's in test mode, first of all. And it's in test mode. So plus 1 and plus negative 6 gives us a -7. So let's put that over there. -7. That is our R square. And we can make a little note of it. We can write it, or we can just put in here that this is R square. Open up the keypad, R square. Okay, that's just a note. Those are my R squares, -7. Okay, and let's look at the next ones are the R's, and we have how many R's here? On this side, we have 7 R's and 5 R's. So we have, let's go to Desmos, and we have 7 R's, and we're going to add 5 R's. Is that correct? We have +7, and we have +5, and we're adding them together in Desmos. 7 plus 5 equals 12. So we have 12R. Yeah, we have 12R. 12R. Right there. And we're going to put that 12R over here. It's a positive. Plus 12R. Okay. And finally, we have our whole numbers. And we have a whole number of 10 and a -18. So 10 plus -18. Let's use Desmos for that. We have a 10 plus, let me use my parentheses to try to keep things neat. Negative, what was that, 18? I think it was. Let me double check and triple check if necessary. No, it's an 8. It's an 18, yeah. 18. Desmos tells me, and I could probably do this in my head, but I get a little confused sometimes. And we don't have any variable at the bottom, so it's just -8. So we have -7, we have +12, and we have -8. That's what our equation looks like. It's what our result looks like. It's -8. We combine those two. Do we have a choice that has -7R squared, these two, right? Plus 12R, these two, but we only have a -8, and we want to double check that. So it seems to us that this right here is the one we're looking for, right? Okay, so let's see if we did our numbers correctly. And that was number 16. The answer was H. And what did we say it was? The answer was H. So, you know, Desmos did quite a bit of work here. And again, you can make notes, you can do the basic math and mark it out, or you can use your scratch pad, or as you can see, we did a combination of the two. But Desmos did help out. So we have a set of inequalities, or an inequality. And unfortunately, Desmos testing mode does not allow you to do the inequalities. So from what I remember, when I was teaching and I had students in algebra, we were able to perform some inequalities in the standard form, which is to say with the way the calculator would have appeared on testing day. And I'm not sure if the policies have changed or if there are just, but I can tell you that there's another calculator that you might want to look at and see if you're able to do these on testing day in your state on your exam, where you may not be able to do it in Desmos. Desmos doesn't do everything that the other calculators do, and vice versa. So if it's possible that this one can be done on another graphing calculator, then why not have both of them? And in fact, you can have both of them. You can have two graphing calculators, actually a total of 3 really, because if you take the online STAAR, as most of you will eventually will be doing, then you will have the option of confirming on the STAAR calculator. Now, if you can't do it in Desmos, I doubt you'll be able to do it on the online calculator. I'm not familiar with that one as much. But from what I remember from a serious competitor, hardware competitor to the Desmos calculator, I do recall being able to do inequalities, and things may have changed. So you want to check it out, and you want to have a backup. So say you don't have a backup, say that the other calculator does not allow the solving of inequalities. So Desmos will not be able to help you, and it will tell you that graphing inequalities are not allowed. Let's see. So y, we can try it. Y is less than 3x minus 4. Okay. So, and we know that there's a value to that, because if we had a standard format of the slope, then we would have a value there. And you can see that these lines match. Okay. Now that they are all at the same place, so it will not help you to plot the line, because they're all at the same value, all at the same slope. And that's not what's being tested here. What you have to do is you have to do some remembering. And this is not on your graphing calculator. This is not on the function sheet. This is not on the formula sheet. This is just you remembering the day of the test, where the shadings go. Okay, so let's go over this. Before the day of the test, please remember, and this will take some refreshing for me also. So shading above the line, greater than. Shading below the line. Okay, so that's actually not above the line. So shading above the line, okay, is greater than. Shading below the line, less than, right? Shading below the line is less than. Shading below the line, above the line is greater than, right? Okay. Now, what's the other thing to remember? Shading below the line for less than or equal to is a solid line, as you see here. Shading above the line, toward higher y values, toward a positive direction, is, if it's a solid line, it's greater than or equal to. Let's go back to these. So below the line, the shading is less than, and if it's a broken line, it's just less than. Shading above the line is greater than. If it's a broken line, it's just greater than. Okay, see if you can remember that. Okay, with that having been said, which graph best represents the solution set of y is greater than 3x minus 4? So we have a greater than. So we have a greater than, and we made a note to ourselves that the greater thans are going to be above the line. So, okay, so that means these below the lines we can get rid of. Okay. And below the lines we can get rid of. Okay. So, so we're dealing with these two, and we said that it does not have a greater than. It doesn't have an equal to. So this is the equal to. That would mean that it's got a broken line. So we have an equal, so we have we'll get rid of that one, and we're left with above the line and solid. And you just have to do your best to remember. And if I remembered all of that correctly, then we will have chosen the correct one. If not, I'll just have to edit out the video, right? Pretend it never happened. All right, so that would be B, and let's see if we are choosing the correct one. All right. And that was 17, I think it was, yeah. 17. Yeah, we're gonna have to do some editing here. Okay, yeah, let's do some editing here because I got a D. All right. A D. Oh, shoot. That's not an equal. Okay. No, it's not an equal to. All right. Made a mistake. See, I get confused with these. I'm not going to edit it. I'm going to let you see how I made that big mistake. I just told you that this is greater than, and it's not equal. So equal to solid, that means I chose the wrong one. So after all that work, I still chose the wrong one, and I'm not going to edit it out. You can see how these mistakes can be made if you don't recall. So I got that wrong, right? Because I just told you that it doesn't have an equal sign, so that should be a broken line. And that is what our answer key has, the broken line above the line. Okay, yeah, kind of embarrassing, but just to let you know, hey, you can't win them all. All right. And let's go on to the next one. And it also lets you know how much I miss Desmos, right? As I sit here looking at this, another word problem. A bank account earning annual compound interest was opened, and no additional deposits or withdrawals were made after the initial deposit. The balance in the account after X years can be modeled by the B of X equals 850 times 1.025 to the X. Looks like part of the formula for interest. Okay, which statement is the best interpretation? Let's read the question again. Well, okay, so let's see. Which statement is the best interpretation of one of the values? Okay, interpretation. So interpretation means this means this. And it says, okay, one of the values in this function, we have the function of X is 850 times that. All right, so the bank is earning compound interest. So that means it's earning money, and the amount of that money goes up. I'm making these little notes. And then if you don't have paper, you could put these in, you can even put these into Desmos if you want. As we showed you before, you can, let's clear all of this. Clear this. So money, earning money. So money, okay. Deposit is earning money. You get paper, and you can represent it as that. The deposit is earning money. No additional deposits were made after the initial deposit, so just one amount. The balance in the account after X years is modeled by function of X equals, okay. So we can throw that in there, I guess. Function, this is Y equals 850 times that amount. to the not sure what that gives us. Not sure if it gives us anything. Let's see. No, it's some kind of curve. All right. Now, there's nothing in the question about graphs or about, well, let's see, it's values. So I guess where does that lead us? It's over here. Okay. 850. Right, 850. And I guess this is the interest. I guess that's the interest. So it's making money, it's going up. So let's see how that helps us. All right. So the initial balance of the account decreases at a rate of 97.5% each year. What's wrong with this statement here? Well, it says the initial amount decreases. All right, the balance decreases. We know that's not true, so that would be false. The balance decreases. It says it earns annual interest. It's right there. It's right there. It's earning interest. Okay, and we can see from the graph that the amount is going up. All right. Okay. But I mean, you know, somebody who's just looking at this might also say, you know, these numbers are going in the other direction. So I'm not sure the graph really helps you in this instance. I'm not sure that Desmos is very helpful. But let's continue on and take a look at the next statement. The balance in the account increases, okay? It increases at a rate of 2.5% a year. Where do we get that 2.5%? Okay, I have this 1 point. So we have 1%, and then let me see something. Okay, so we have that, and if it's squared, right, still wouldn't get us 2.5%, but it's compounded interest, and it works kind of strangely. But there's some kind of an increase, right? And oh, actually, it's 850 times that. So maybe we can plug in, oh, we never said it was squared, right? Okay, it's some kind of compound interest. It's some kind of an increase over here. It's some kind of an increase going on, yeah, because 850 times that amount raised to whatever exponent it is, that's going to be a bigger number, right? Okay, so whatever that exponent is, that exponent could be 1, and we still have some earnings. But whatever it is, there's an increase. So there's some truth to this. So let's give it a question mark, because the balance does increase. We don't know exactly how much. It could be 2.5%, but oddly enough, at least we have 1% here and 2% here, and that's closer to the truth. And again, this compound interest, just remember that that's not an exact number that you can say multiply by 2 and add 3, or, you know, it's interest. It works rather oddly. But let's take a look at the other one. The initial balance in the account was 1,025. Is that true? Is there anything that says that that is true? Okay. A bank account was opened. The balance in the account can be modeled, but it never says, okay, 1,025, that number and that number are not the same. This is 1%, and this is a figure that is $8,000 plus $25. So these are not the same numbers. And so there's nothing to say, any information here to tell us that we know what the initial amount is. All right, let's see. Maybe we can guess. Maybe we can guess that 850 was the initial amount, right? It has to come from somewhere, but it's not 1,025. All right, so I would, let's see, probably say that number is made up right there. Not true. The balance in the account at the end of 1 year is 850. Can that be true? Well, it says we know from the beginning the bank account earned interest. That means it made money. So if we take a guess that maybe that was the beginning balance, 850, could it be 850 at the end of the year? There's our 850 again. 850 times this number, 1%. And think about it. Does that sound like it might be the amount of interest you get at a bank? These days, probably so. These days, and at the time that this video is done, you're lucky to get 1%. So that's a realistic number to expect an initial amount, an initial deposit. We are told no additional deletions or deposits or withdrawals are made. And so if that's the number, it stayed there at the end of the year, okay? But we know it made interest because it's 850 times that raised to some power. So there's some kind of growth, and we see in Desmos, we can illustrate that. 850 times 1% raised to some power, even if it's 1, even if it's the power of 1, which we don't write, then it's still higher than 850. So that leaves us with a false statement. And what can we do with that false statement? Let's say that we're not going to fall for that false statement. So we're left with G. Let's see if what number is that? That number is 18, right? G, correct. So Desmos wasn't much help, but at least it keeps things clean. It lets us visualize things. So small bit of help. A lot of it is reading the question and making sense of it. So what do we have here? Another word problem. A word problem with a table. And I have suggested in the past to create the table. You've got time, you've got a great platform with the Desmos that allows you to quickly and easily create a table and to see the lines that are made from it. So let's go ahead, let's read this question. A company collected data for the number of text messages sent and received during a text message application since October 2011. The table shows the number of text messages sent and received in billions over time. The data can be modeled by a quadratic function. Not a quadratic function, okay? So if I have paper, I'm taking notes. So there's data and text messages. And there it is, text messages, sent and received. All right, sent and received. The table shows the number of text messages sent and received over time. So the number of text messages sent and received over time. Okay. So text messages, number of text messages, and time. And I usually say just do X and a Y, but I like to do the time as something that goes up. And I usually like to do time as Y. So why don't we do that? The text messages, that amount is going to go up over time. And I usually like to put the time as Y. So let's do that. Yeah, let's do that. We have a plus sign here, and we're going to use that to create a table. And so in my X's, I'm going to use 3, 10, 17, 27, 44, 64, 86, 112. That's the text messages. And over the time of 5, 10, 15, 20, 25, 30, 35, 40. Okay. All right, so let's see, 5, 10, 15, 20, 25, 30, 35, 40. That's kind of rhythmic, kind of looks like a pattern, huh? 3, 10, 17, 27, 44, 64, 86, 112. And the question is, which function best models data? Oh, okay, it's a quadratic function, right? Yeah, this model. All right, so let's take a look at that. And I'm gonna take this as a quadratic function. So we know what that looks like. We had our quadratic function before. Okay, right there. We're looking for this kind of number, right? Okay, so let's see what our table sees. Okay, all right. Click here, read a line. All right, so it looks like it's a, let's clear that. And it looks like it goes off. All right. Text messages, time. Okay. So what can we make from that? Let's see. Number of text messages over time. All right, let's see. 10, 10, 17, 15, 27. Well, let's do this. Let's enter these into Desmos. Let's enter these into Desmos. Hope we're doing this right. Okay. Let's see. So the first one is, okay. All right. Okay, and let's do this, fix this up, square, and 55t plus 502, and remember that this is just y. You can leave it as function as t, I don't like that. Okay, all right. So let's look at the next one. Okay, B. Okay, I just copy, paste, and I tweak these. 172 t square minus 15t plus 2.73. Okay, that's looking like that. Falling over there, okay. Make sure you're doing it right. Okay, next one. Looks like the first one. Copy, paste into that. And the difference is it doesn't have the quadratic. Okay. Negative 0, 0, 0, 2. Okay. All right. So that's that one. Y equals negative 0.002t squared. Okay. All right, so that's that one. And let's get a different color. Okay. All right, let's do this. Let's do that one. It looks like the second one. Copy, paste into the second one, and what we're changing is we're eliminating the middle value, the b, the b, I guess. Negative 0.0072 t squared plus 2.73. Okay, all right. And let's get a different color for that. Okay. Is it falling off? This is falling off. This is falling off. This is more in line. So take a guess as to what value it looks like, because the question is, okay, the data can be modeled by a quadratic function. Which function best models the data? All right. These are falling off, but this is pretty much keeping in line, isn't it? Would that be what they're talking about? Okay. Well, let's find out. That one falls off eventually. Okay. Okay. So that's the first one. Okay, well, that's the one that closely matches. The other ones do not, and that is A, isn't it? Okay. Let's see. We'll look over one more time to make sure we got this right. Okay, and let's go over back to our Desmos. Okay, it's we got some similarity here, but it falls off. It falls off, and that's troubling. Not convinced. Let's look at these values. Let's take a look at them. Got another window here. Okay, hold on a second. 0.0.2, 0.007. We got a mistake. Okay, that was our second one, and actually there's another mistake. Okay, -7. Okay, still not matching up. -0. Should I accept this one? I don't know. Why would the numbers fall off? Okay, let's see if there's another mistake. 0.072 square minus 15t plus 2.73. Okay. 0.72t squared minus 15t. Okay, well, let's take a look at this one. That one looks fine. -2. Still, I'm expecting. Let's see. Okay. Why would the numbers fall? If these keep going in this direction, they would be going up, and this one falls down. I would expect it to continue. So if we put more values, it's going to go off. So let's see, I'm kind of wondering. So I used the X and the Y exchange. Let's find out what happens if we don't exchange them. Maybe it does make a difference. Maybe when they give it to you, they're giving you the X and the Y. So let's take a look at that. Let's recreate the chart. We got time, right? Sure, you can just day of the test. You have 4 or 5 hours. Some of you have all day, literally. Let's create a table and let's put the values as they gave them to us. 5, 10, 15, 20, 25, 30, 35, 40. Okay, and let's get a different color. Let's put a green line. Okay. And so that will be green when it comes in. And 3, 10, 17, 27, 44, 64, 86, 112. Okay, so these are going this way, but we don't have any going that way, so that's even further off. Now let's take a look at our equations one more time. Negative 0.002 squared plus 0.55t plus 502. The second one, y. Okay, all right. Oh, okay, all right. I don't know why I didn't catch that before. Well, that's what happens sometimes when you're at this test for a while and when you're only on 17 and you start to get drawn down a bit. And hopefully by about this time, lunch will be called. So yeah, that fits in. And look what happens. Remember what I was saying, that this doesn't make sense because the values are falling off. Here, the values do not fall off. They're actually, that makes sense because we expect the number of text messages to go up, not down. And that's a perfect match, almost. Okay, so we have this one and we have this one. So which one should we choose? Probably the one that makes more sense, in the sense that we expect that the number of text messages will go up. That would be A, right? A? No, that was B. We had a lot of trouble with B. All right, okay. There's a lot of trouble with B. All right, okay. Yeah. Well, here we go. 19 is B, right, okay. Holy Desmos, what will we do without you? The graph of a linear function is shown on the grid. Okay, graph, good, graphing calculator. Looks like we might be able to use Desmos on this. So the graph of the linear function is shown, and we have 2 points, and let's go ahead and plot those. Well, let's read the question, right? What is the rate of change with respect to this function? So we remember those words, rate of change. We remember that we have on our sheet, the rate of change is equal to, and see if we've memorized them. Get rid of all this here. And remember that from the formula sheet, it's m equals a fraction that is the change in y, y2 minus y1, and it's over x2 minus x1. So that's the formula, and that's in your formula sheet. You can look back to that. So we just put that there to remind ourselves. And so that we're given these points, and that's, so let's mark that as y2 over here, and we'll mark this as x2. Okay. And this will be, oops, look at that, making a mistake again. Okay, y2, see, that's why it's good to mark them up. Y2 and x2, we're going to take these values away, and that's x1 and x2, or x2. So it can be confusing, x2, x1. So somewhere have that noted that you are going to remember your formula in the correct order, right? And I marked it right there in Desmos. So that I set up the fraction, or I set up the fraction like that. And I'm actually looking at my points over here, and I have a 5. Remember, the Desmos testing format has the, okay, let's see. See, doing it reverse again. Okay, I just said that y2 is going to be the second one here. This is y2, so that's be a 2 minus a 6. okay? And okay, probably time for lunch after this. Add 2 minus 3.6, and then the x value of 5 is going to take away a minus 3, so let's keep it in order and put a fraction, put the parentheses, minus 3. Okay, and that gives us a value of negative 0.2. Now watch when you click on here, we can actually turn that into a fraction. So which one of our answers looks like that, negative 1.5? And we want to double check to make sure. 2 minus 3.6, 5 minus a minus 3. Just double checking 2 minus a 3.6, 5 minus a minus 3. Let Desmos do the math. And that gives us negative 1/5 or negative 0.2. Either one of those could be the answer. And in this case, remember that they're asking you to fill in the bubbles in your answer sheet. So I'm not sure I remember how you would put in a fraction, or maybe they want you to put in the decimal. So in any case, you have both of them here in Desmos to provide them with. All right. And so we would put in a negative 0.2. Now, how could we, we don't have multiple choice. We don't have our powers of eliminating bad answers or getting the best one. We actually have to get it right here. So if we want to be sure that we have it correct, maybe we should have a backup. And in this case, looking at our graphs, let's clear this up. And remember that there's another method by which you could tell. So is this a negative slope or a positive slope? It's going down in the negative direction. It is a negative slope. So that makes sense. Our Desmos says we have a negative slope. Okay, so that part works out. Now remember the rise over the run? Well, you have the opposite in a negative slope, and that's the negative, the fall over the run. So which means that we take 2 good points, and we don't want them in the middle of the line like that. We actually want them like this here. We actually want them to be nice, clean points. And we take a, let's see, a nice clean point elsewhere. And that's not very clean. It's not very clear. I'm not sure if that's exactly on 3. Let's take about, let's see. Okay, so let's see. Back to our Desmos. There's our numbers. So we got somewhere it's going to fall in the middle. All right. Take a look at this. All right. Okay, so let's see. I guess we'll have to live with that one. Okay. We'll have to live with that one for now. Okay, one good point here, one good point here. Okay, let's fall down one value. And so this is the fall over the run. Is going to be the fall. So the fall, we fell down 1. Okay, and we ran. How many did we run? We're going to roll 1, 2, 3, 4, 5. Okay. Oh, by the way, that's not a 1. That is, we fell down in the negative direction, so that's actually a negative 1. All right. And we did 1, 2, 3, 4, 5. We always run to the right. Okay. And we ran 5. So that's negative 1 over 5. You see that? And does that match up over here? Negative 0.2 or negative 1/5. So that's a way of confirming. And if that point wasn't good enough, you could get 2 other points. I didn't like this point very much, but it does match up. And if you fall down 1, 1, 2, 3, 4, 5, down 1, negative over 5. So still negative 1/5. So again, you could have done it without Desmos, but sometimes it's hard to see that those are actually on the point. And it's better to use the Desmos, do the math, do that formula, do those fractions and those combining of terms in Desmos, and leave the counting just as a way to confirm the answer that you got in Desmos. And there you have it. So you have had 10 additional problems, and we have used Desmos in 6 of the 10. And even when the problem did not call specifically for graphing, it was useful for smaller things such as basic math. And we know that a lot of students make mistakes with a negative sign. You saw that I did it myself. You see that you can use Desmos to confirm numbers when you have periods, coordinates, dots, negatives, and then you have combining. A lot of potential for error. Desmos keeps it clean. You've seen that. And so in the last 10, we have used Desmos for 6 of the problems. And so that's 6 out of 10. We did 9 out of we used Desmos for 9 out of the 10 problems. So that's now 15 out of 20. And that is a 75% usage rate and we're just only done with half of the test. So we will move on, but for now, we'll leave you to review these past questions and see if you can come up with more creative solutions or uses for Desmos.